you're fine. All right. Good afternoon. We are knee deep in fraction work. I think I said that yesterday. But anyways, here is my funny joke for today. And I may have used this one already. I don't remember, but I think it's really funny. Okay. So why don't you argue with decimals? Because they always have a point. I think that's really funny. Decimals have a point. They're like fractions with decimals. No, I don't think your face could be on it.
No, I just want to say hi.
All right.
Peace
Sure. Okay.
Hi.
These are imposter children.
Yeah.
But I'm not sure if kids' faces can be on YouTube, so I'm just trying to be safe, and we can research it later.
My name. Wait, hey, my name is Yamaya, and we are in Bowie, the best class ever. Don't play with us.
Okay.
Don't play. I'm Emily.
My
name is Zalea. You already know. Don't play.
What do you already know? I'm just kidding. I already know. Okay. All right, here we go. Here is our hey. Happy birthday. All right. So like I said, we are working with fractions, and when you are adding mixed numbers, obviously you can read this because this is by you. We have to make sure that the denominators are the same, and then that requires quite a bit of work. So how are we getting from 2 to 6 and 3 to 9 in this case? Hopefully, we know that we are multiplying by 3 over 3 because we want 9 in the denominator here. I left this open so that you could practice. This would be times 3 over 3, and we get 6/9, and then 9, this is a freebie, so it's going to stay 8/9. If your new fraction is an improper fraction, like it is here, you can convert it to a mixed number. Oh, sorry, when you add them, that's fine. And then combine it with any other whole numbers if you need to from the beginning. Okay. All right. Let's look at the first problem. Here it goes. All right. This is subtraction directions, just to give you some, you know, like a criteria for success, or like an anchor chart, so you can refer to it. When we are subtracting, we're making denominators the same thing over and over again. Then we are subtracting the fractional part. If the fractional part is too small, we have to regroup, which means get some from the whole number. Then subtract the whole numbers. Here we go. And then in this case, you have to use the denominator, the new denominator, to make the form of 1. Okay, that's actually super fun stuff. All right. Carpenter has 10.5 feet. Looking like this. Carpenter has 10.5 feet. There we go. Of wooden plank. He cuts off 4 1/4 feet to replace the slat of a deck, and 3 2/3 feet to repair a banister. He uses the rest of the plank to fix a stair. How many? Ooh, okay. So I have a whole plank. It is 10.5 feet. He's cutting off 4 1/4, and then 3 2/3. These are not drawn to scale. If you've read any math textbook, you'll recognize that. It always says not drawn to scale. And then the rest is to fix staircase or something like that. All right. So we need to know this. So I am basically taking 10.5 and I'm subtracting 4 1/4 plus 3 2/3. Okay. So I'm going to add those together first, then I'm going to take them away. So I'm going to put this on hold, split this area in 2, and I'm going to first do 4 1/4 plus 3 2/3. Luckily, my denominators are 4 and 3. So I'm going to set the table, and I know that my new denominator is going to be 12. And 4 times 3 over 3, 3 times 4 over 4. 4 times 3 is 12, 1 times 3 is 3. New numerators are essential. 3 times 4 is 12, 2 times 4 is 8. So now I have 3 12s plus 8 12s, that's 11 12s and 7. Okay, so now I have 10.5 minus 7 and 11 12s. I added first. You could have subtracted 4 1/4 and then subtracted again. I think subtraction is a little bit tougher than addition. So I wanted to add first and then just subtract once. But I have 10 and a half minus 7 and 11 twelfths. Okay. So I actually foresee quite a bit of extra work here. First, I need the denominators to have 12, right? So this is going to stay 12 and this is going to be 12 times 6 over 6. And I'm going to get 6 twelfths. We know 6 twelfths is half of, is 1/2 of 12 is 6. Okay. Then I have 6 twelfths minus 11 twelfths, but I can't do that. So I have to, on this anchor chart, it says regroup, but I call it borrowing. Knocking on the neighbor's door. Can I borrow some twelfths? I promise they're the same size. So I'm going to turn this into 9. And then I'm going to release 1 that is 12 over 12. This is a form of 1. And so 9 plus 1 is 10. That's what we had. And so now we have 12 twelfths plus 6 twelfths. That equals 18 twelfths. That's the improper fraction. That includes the whole number, like when we convert it. And so really it's 9 and 18 twelfths minus 7 and 11 twelfths. I have 18 minus 11 twelfths, and I have 9 minus 7. How much is left for the stairs? 2 and 7 twelfths left. Feet. Actually, I'm going to write feet here. Left for the stairs. Okay, so a lot was happening in this problem. I added what I had to take away, then I took it away, and I did have to borrow because I knew 10 was big enough to take it away, but I had to get it in the fraction form. So I made one of my whole numbers a 12 over 12, and the 12 denominator is what determined that. Okay, next problem. Each student in a class participates in one of 3 after-school clubs. Oh, okay. So that means that the whole class is split. So it looks like 4/10. So here's an entire class. Okay, is 4/10, and then 1/3, and then what? Okay. So I know that the whole class is going to equal 1, or when we see the denominator, you'll see what I'm going to do. So let's get rocking. 4/10 plus 1/3. 3, 6, 9, 12. Boom, boom, boom. I'll just keep going, actually. 15, 18, 21, 24, 27, and 30. 10, 20, 30. That helps me determine the best denominator. And now I'm going to set the table. Once I finish the denominator, I'm going to set the table. My cups, my plates, my napkins. Now, I got to deliver the food. 30 divided by 3 is 10. 10 denominator, 10 numerator. 1 times 10 is 10. No, I'm sorry, 30 divided by 3, yes. 30 divided by 10 is 3. 3 denominator, 3 numerator. 4 times 3 is 12. 12 plus 10 30ths is 22 30ths, which means 30 30ths minus 22 30ths. This is the whole class. This is the 2 clubs equals the last club. Okay. Right. So we had whole class equals robotics club and tech and debate. Okay. Tech and debate is 22 30ths. Together, this is 22 30ths. Could also have had 11 15ths. All right. Then realizing that I have to get whole class, which means like this whole fraction, I'm going to take this away from 1. And the form of 1 whole equals 1. And in this case, we have 30 30ths or 15 15ths minus 11 15ths. And that would be 4 15ths. So 4/15 or 8/30, which is what this would be, is the answer to the remaining last club. You could have had it in 30ths. You could have had it in 15ths. I realize that a lot's happening here and that this idea of a whole class being equal to the 1 and taking away the fractions is something new. But that's the only way to figure out like what fraction would be the robotics club. And so in this case, it's 8/30. Okay. That was fun. For a large order, Mr. Dorman made 3/8 kilograms of fudge in his bakery. Love bakeries. And then he got 1/6 kilograms from his sister's bakery. Oh, it's a family of bakers, baker family. If he needs a total of 1.5 kilograms, how much? Okay. So we need 1.5 minus this sum, 3/8 plus 1/6. So I'm going to add that first. Same thing I did earlier. First, I'm going to do 3/8 plus 1/6. All right, so 3/8 plus 1/6. What could be my denominator? 8, 16, 24, 6, 12, 18, 24. Nice, setting the table. 24, 24 times fraction, times fraction. 24 divided by 6 is 4. 4 denominator, 4 numerator, 4 new numerator. 24 divided by 8 is 3. 3 denominator, 3 numerator, 9. I have 9 plus 4 24ths. That's 13 24ths. Okay, I'm going to take that away from 1.5. And in this case, I'm actually going to turn this into 24ths right away, which I know is 12 24ths. I don't always have to like show all of this steps, especially if it's like the half. And I am subtracting 13 24ths. But I have this 1 and 12 24ths. I'm going to turn that into an improper or a fraction greater than 1. And that's going to be 24 plus 12. That's 36 24ths. And then I'm going to subtract 13 24ths. Okay. And so now I have 36 minus 13 24ths. I hope I didn't make a mistake. Last night's homework, there was 2 mistakes. 36. I'm going to subtract vertically, so I have less opportunity for mistake. Okay. So I'm going to get 23 24ths. So it looks like he needs to make almost a whole kilogram. All right. Mr. D needs 23 24th kilograms of fudge. Okay. All right. Well, that was, again, pretty fun. Adding first, then subtracting. This expression right here, we're not too old for us to be writing and thinking this way. Yeah, so definitely like, push yourself to write that expression based on the words of the problem. Okay. All right, last page. Just an answer check. Converting each mixed fraction into an improper fraction. Just to review, this is saying I have 9 sets of 9/9 plus 1/9. So it was 9 sets of 9/9, which is 81, plus the 2 at the top, 9ths. That's why it's 80 plus the 1 at the top. My bad. That's why it's 82 over 9. This is 3 sets of 9/9. It's a little bit easier when it's just 3 sets. And then plus the 8/9. So that's 27 plus 8/9. Okay, that's 35. So same thing here. What's a smaller number? So I can just draw it. Here we go. 2 sets of 10 over 10, because that's 2 plus 7/10. So the smart cut is denominator times whole number plus numerator. Okay. Okay. Oh, okay. I definitely have done a better job of pausing. Yesterday I stopped it. Anyway, all right, let's do one more where we're finishing up here. Okay, so I have 3, in this case, it's 3 and 4/5. So it's 3 sets of 5 over 5, because that's 1. Right? plus 4/5. That's how I get 5, 10, 15, 19 fifths. Denominators stay the same. And then the smart cut that people use is that they do 3 times the denominator, 3 sets of 5, 15 plus the numerator. It's one way to do it. And then reverse, beep, 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 backing up. Reverse, you would divide numerator by denominator and then subtract, right? So 27 divided by 7. 7 goes into 27. 7, 14, 21, 28. Oops. So 3, 21, and then I subtract. And I have 6 out of the next group of 7 because this would be 7 sevenths plus 7 sevenths plus 7 sevenths plus 6 sevenths. 7, 14, 21 plus 6, 27 over 7. It's 27 sevenths, right? Okay, let's look at 19 eighths. 8 goes into 19 twice because 8, then 16 is the multiple, right? And so then it goes in 2 times for the whole number. And then I have 19 minus oh, I got this wrong. Good thing I'm picking it. I have 19 minus 16 is 3. So I would have 2 and 3/8. And then 16 plus 3, 19. Okay. So double checking your work is important. And then here we go. 3 and 1/12. That's 12 twelfths plus 12 twelfths plus 12 twelfths plus 1/12. 1/12. That's 36, 37 twelfths. And that's what this was, right? So that's 3 sets. That's 1, 2, 3, and 1/12. Please double check, triple check your work and my work. And I'll see you tomorrow. Can't wait to see who's going to be our pie representative for 5th grade. Good night.